So we are going to complete the session on cyclotomic extension with one of its application on geometry. Geometrical constructions. Our question is to find the condition for a regular n-gun to be constructed using compass and straight edge. So before we start this problem, we'll borrow some results from our previous discussion on geometrical constructions. This is actually an application of cyclotomic extension. So the result which we are going to borrow is this. One is a real number gamma can be constructed. I'm going to write again using compass and straight edge if the degree of the simple extension gamma over q is equal to power of 2 for some integer r greater than or equal to 0. The second result is an angle theta can be constructed if cos theta as a real number can be constructed. And the third result is an n-gun can be constructed. This is actually a corollary of these two, a consequence of these two results. N-gun can be constructed if cos 2 pi by n can be constructed. This is because this is the external angle of an n-gun. So these are the results from geometry. We have some more results from the previous sessions that we are going to use it here. This zeta equal to cos theta plus, cos 2 pi by n plus I sine 2 pi by n is a prime or nth primitive root of unity in Q. This is because n zeta to the power of n is equal to cos 2 pi by n plus I sine 2 pi by n to the power of n, and you can calculate that is equal to 1. And if m is less than n, then zeta to the power of m cannot be 1. You can verify this. So this is a nth primitive root of unity. If zeta is this, then 1 by zeta, or you can say zeta to the power of minus 1, is equal to cos 2 pi by n plus I sine 2 pi by n to the power of minus 1, and that is cos 2 pi by n minus I sine 2 pi by n. So if you add these together, say plus 1 zeta is equal to 2 cos 2 pi by n. So here it says an n-gun can be constructed if cos 2 pi by n can be constructed. So that implies an n-gun can be constructed if zeta plus 1 by zeta to the power of if zeta plus 1 can be constructed, where zeta is nth primitive root of unity over. So this is the fourth result. These are the results which are going to use it for deriving a condition to construct a regular n-gun. So let us recap that result. Gamma belongs to R is constructible implies Q of gamma over Q is equal to 2 to the power of R for some integer R greater than or equal to 0. And zeta is a primitive root, is a nth primitive root of unity, implies n-gun can be constructed if zeta plus 1 by zeta can be constructed. So we combine these together, what we get is an n-gun can be constructed if the simple extension, the degree of simple extension zeta plus 1 by zeta over Q is equal to 2 to the power of R for some integer R greater than or equal to 0. If you are combining these two. Now let us take a simple a splitting field. Let K be the splitting field of x to the power of n minus 1 over Q. that implies K is a finite normal extension of Q. And the degree of K over Q is equal to the Euler function. And that is actually equal to the index of, and that is actually equal to K over Q of zeta plus 1 by zeta times Q of zeta plus 1 by zeta over Q. Because this is in between K and Q. Now what is this? This is actually K of Q, K over Q of zeta plus 1 by zeta is equal to K of Q of zeta plus 1 by zeta, and this is the number of automorphisms on K leaving Q of zeta plus 1 by zeta fixed. So what we are trying to do is, we'll see every automorphisms on here is an automorphism here. So it means sigma belongs to G of K over Q of gamma zeta plus 1 by zeta implies sigma belongs to G of K over Q. But sigma belongs to K over Q implies sigma of zeta is equal to zeta to the power of R for some integer R. That is because K is spanned by the primitive roots of, K is the splitting field, so it is spanned by the primitive roots of xn minus 1, and gamma is a primitive, zeta is a primitive root of unity. So this actually means that an automorphism on K leaving this fixed, that is Q of zeta plus 1 by zeta. So we want a condition on R such that sigma, when it takes an element from K, leaves Q of zeta plus 1 by zeta fixed. So let us compute gamma of zeta plus 1 by zeta, and that is equal to zeta to the power of R plus 1 by zeta to the power of R. We want that to be zeta plus 1 by zeta, right? So this is possible only when R is equal to 1 or n minus 1. Because if you calculate the values, you will find that. So that means G of K over Q of zeta plus 1 by zeta contains only two elements. Now we'll substitute here. This is an equation number 1. So from 1, if n gun are to be n-gons are to be constructed, then phi of n is equal to this is 2 times, this has to be 2 to the power of r, and then only this n-gun can be constructed. The n-gun can be constructed only if this is true. So that means 2 to the power of r. So this is the condition for an n-gun to be constructed. And that is actually equal to phi n is, that means phi of n, that is Euler function of n, is a power of 2. Now we have a result from number theory on phi of n. That is, if n is equal to 2 to the power of v times p1 to the power of s1 times p2 to the power of s2 times dash dash pt to the power of st, you can factorize any integer in this form. If n is equal to this, then the Euler function n is equal to 2 to the power of v minus 1 times p1 times p1 to the power of s1 minus 1 times p2 to the power of s2 minus 1 times dash dash pt to the power of st minus 1 times p1 minus 1 p2 minus 1 dash dash pt minus 1. This is a result from number theory. We have used it earlier. Now, if n-guns are to be constructed, this product have to be a power of 2. Okay? So, for n-gun to be constructed, phi of n should be a power of 2. And that implies this is a power of 2. All these are primes other than 2. So if the product have to be a power of 2, these individual powers of these prime numbers have to be 1. That means pi of si minus 1 have to be 1 for all I. And these are all have to be powers of 2. Each of them have to be powers of 2. So pi minus 1, see pi's are all prime numbers. Pi's are all powers of 2. That implies si minus 1 is equal to 0 or si is equal to 1, and pi's are of the form 2 to the power of m plus 1. See, this is actually power of 2. So pi, each prime factor other than 2 have to be in this form. So this actually, what does this imply? This implies that pi square does not divide n. It should occur only once. This implies pi square doesn't divide n. And this actually means this is called okay. See, PIs are of this form, and PIs or primes of the form 2m plus 1 happens or occurs only when m is equal to a power of k, a power of 2. This is also a result from number theory. So combining these two, all primes other than 2, that is PIs, PI square does not divide n, and this is called, when it is of this form, it is called Fermat's prime number. It's called, and Pi is equal to 2 to the power of 2 to the power of k plus 1, which is called Fermat's prime. Here, what we need to note that for every k, this does not be a prime number. And not all prime numbers can be expressed like this. If a prime is expressed like this, then m is equal to 2k. That's all. So the condition for an n-gun to be constructed is this. An n-gun can be constructed if the square of all prime numbers, prime factors other than 2 does not divide n, and all prime factors of n are Fermat's prime. If these two conditions are satisfied, then that regular polygon can be constructed. We are going to complete this session on cyclotomic extension with one problem which is going to clarify the theorem which we proved just now. The problem is this: find the smallest constructible angle the smallest integral constructible angle. Meaning that angle has to be an integer, not any, we don't want any decimals. So it has to be from the angles 1, 2, dash 360. We want to find out the smallest angle from this collection that can be constructed. We don't want 2.3 or 17.6, things like that, just integers. That is why this is called integral. So before we go to the problem, we'll state the theorem one more time. An n-gun can be constructed if the square of any non-2, a number other than 2, non-2 prime factors of n does not divide n, and every prime factors of n are Fermat's prime. See, these angles 1, 2, 3, etc. are some of them, not all, are the external angles of some n-guns. For example, 1 degree is the external angle of 360 gun. Meaning if you have a polygon with 360 sides, a regular polygon with 360 sides, each angle is going to be 1 degree. And 2 degrees is the external angle for 180 gun. 3 degrees is actually 90 gun. Sorry, it is 120 gun. And 4 degree is 90 gun. So we are trying to find out, see, if you can prove that one of these can be constructed, then these angles can be constructed. So let us first attempt is to find out whether this can be constructed. If it's not possible, go here. If not possible, go here, because we want to find the smallest one. So in order to find whether 360 gun is constructed, we need to find out this 360 satisfies all these conditions. So 360 is equal to 2 cube times 3 square times 5. 945 times 8, 360. See what is happening here? It says that the square of any non-2 prime factors. Non-2 prime factors are 3 and 5. So 3 square, the square of non-2 prime factors, so 3 square divides 360. So this condition does not satisfy here. So since 3 square divides 360, 360 gun cannot be constructed. 180 is equal to 2 square times 3 square times 5. Same reason, 180 gun cannot be constructed. So this means that 1 degree cannot be constructed. This means 2 degrees cannot be constructed. Let us take 120. 120, 60, 30, 15, 3, 5. So this is actually 2 cube 3 times 5. Well, this condition is satisfied. Square of any non-2 prime factors does not divide n. That is fine, because we don't have 3 square or 5 square or any power higher than 2 for the factors other than 2. But still we need to prove that every prime factors are of Fermat's number. 2 is definitely a prime factor, a Fermat's number. Here so here the square of prime factors of 120 other than 2 doesn't divide 120. Now we need to prove that 2, 3 and 5 are Fermat's number. 2 is equal to 2 to the power of, okay, you don't need to consider 2. You consider only 3 and 5, because Fermat's format is 2 to the power of 2 to the power of k plus 1. So if there is a plus 1, definitely 2 is not included here. So here you are not including 2. You are only considering primes other than 2. So we'll see 3 is equal to 2 to the power of 2 to the power of 0 plus 1. This is of the form 2 to the power of 2 to the power of k plus 1. And 5 is equal to 2 to the power of 2 to the power of 1 plus 1. So that implies 120 gun can be constructed. That implies 3 degrees can be constructed. And that is the smallest integral constructible angle. 1 and 2 are not integral constructible numbers.